So this is the first time when we are in Russia as speakers, and we are very happy to be at Mobius 2011 in St. Petersburg. And we want to thank organizers and program committee for accepting our talk. So I'm Ewa.
I'm Aleksander.
We work in the same company, on the same project, which is Allegro application. It's like e-commerce app like Amazon or eBay, but it's in Poland. And this is an app where you can search, buy, and to purchase goods. And right now we are in the top 7 in a shopping category in the Polish App Store. And we have around 500,000 unique users per month. So we will not theoretically explain what different test types are. We believe that everybody is more or less familiar with the concept of unit tests or functional tests. Instead, we will focus more on problem-solution approach. So we will discuss 8 real problems, issues that we experienced in our project, and we will discuss more about test types that helped us to solve these problems. We really like the problem-solution approach because we believe that learning through your mistakes is the best way to learn, even if it sometimes hurts, and we also think that it's worth sharing. Okay, so let's start with the first layer, problem and test solution. This is the exemplary code, it's not production one. It's just here to illustrate the problem we experience in our project. So you have a fake function that finds category that is related to the family. So it first checks whether the name of the category is non-empty. Then it checks whether the name is equals to children and baby or toys and games. Then it has another if and also handles 3 else statements. So you can probably easily see that even though the problem is quite trivial, the code is quite complex. So in our project, unfortunately, we are dealing with code like that, this kind of code smell, because I treat it as a code smell. It does not have to necessarily cause bugs, but it definitely is quite hard to read, understand, refactor, test, and maintain. And in projects like ours, we need to be ready to maintain code for at least some time. So we were thinking how we could prevent this problem in the future, regardless of code review level or a developer's experience. So this is the image that actually our common friend sent me a few days ago, and I believe it illustrates the problem nicely. This is your code at the very first release. Then you do some unplanned changes, holiday commits, and first refactor, and sometimes it looks like that. So we don't want to create... Oh, I can, if you want a picture. I really like this. This is a really cool place to find more comics like that if it's turn-off.us. So to avoid creatures like that one, we started using Swiftland, which is linter for Swift. I'm quite sure you are familiar with what linter is, but just to be sure, could you give me its short definition of linter? Although maybe...
So linter checks your code and validates it if there are any rules validation breaks.
Yeah,
something like this.
As far as style is concerned, but also as far as bug smells, like the code shown in the previous slides. So we use Swiftland, but of course we started... why we used Swiftland actually? There are many tools out there. We know that there is, for example, SonarCube or Taylor. We chose Swiftland because it has wide set of rules. And it's also open source and it's actively maintained. And it's also used by other companies like Kickstarter or Lyft. And we did in Swiftland all the things immediately. This is how it looked in practice. So our application consists of many modules, and all of the modules were developed in time by different developers. They have a little bit different style, which is actually okay for us. So we knew that we need to approach them individually. So what we did, we started with the default set of rules, and then for each module individually, we were configuring some of the rules and removing some others. So this is how the exemplary configuration file looks like. It's called swiftland.yml. This is the place where you can, for example, exclude some of the files that you do not support, for example. These are external libraries, like, for example, some pods you are using. You can disable some of the rules, like, for example, in our search module, we disabled identifier name rule, which is saying, for example, that your constant or variable name should not be too short, like this one, for example, or it shouldn't be too long, like this one, browse category button container zero width constraints. We have many long variables like that. I'm not sure how it looks in your project, but we definitely are handling with this problem. And we knew that there is a software metric called cyclomatic complexity that could help us to monitor the problem with the complex code that we have. So here, for example, we configured this rule. So it will always warn us if the complexity will be higher than 7, and it will give us an error, so you'll be not able to build a project if this value will be bigger than 10. These are more strict values than default ones, because default ones are 10 for warning and 20 for error. So as far as we were talking about linting, we had also vivid discussion within the team about formatting. We also decided that instead of only marking violations, maybe we could also format violations automatically. This is why we started using Swift format. Again, we didn't Swift format all the things, but we were able to choose one common set of rules for entire project for all of the modules. And you can also configure some of the modules. So for example, we decided that we don't need a header that is appearing at the beginning of the file. We decided that we want to disable some of the rules, like number formatting. So this tool is also fully configurable. So to sum up, we knew that formatting and linting procedures need to respect our modular architecture of the project. So that was quite obvious to us, and we respect the different style and different modules. We run our formatting and linting procedure locally. It's a build phase. It's one of the build phases in our project. And it's run only locally because when we are running it on our CI server, it prolonged the build time significantly, even up to 4 minutes. So we decided that it is responsibility of developer to run it locally on the personal computer. We also format obvious rules, so the ones we all agree on, and we lend less trivial ones, giving the developers a space to decide whether this violation should be fixed or this rule can be also disabled. So we apply formatting and linting procedures to our production code, but also for test code, because we believe that test quality is also important. And we also use the same version of tools, formatter and linter. They are stored in our repository, so if somebody checks out the repo, he or she is ready to format and lint. And we are also sure that we use the same version of rules, so we are consistent. Okay, so that was the first layer, how we solve the problem of complex code with some static analysis tool. Now let's move to the second layer. Again, here is some exemplary code. It's not production one. It's again here to illustrate the problem we experienced. So here is this very short class called category fetcher, and it has a function fetch, and it has 3 parameters, which is category name, success, and failure closure. So what the function does, for each non-empty category name, it calls the success closure. What is important? Asynchronously. What is more interesting for us here is this simple test that is first creating an instance of category fetcher, and then it's fetching the category for non-empty category name. This test will pass only in case of failure, and that then will fail will be called. There's a question for you if you see something suspicious in this test, if you think it will pass or it will fail. What's your impression? Yeah, exactly. The idea is that the success closure is called asynchronously. So this test is likely to complete before the actual fetching will complete. So this test will always pass. So even though we will change the success for failure or failure for success, we will rerun the test, it will be still green because the call is asynchronous. So we had, I think we also have right now some tests like that are still undiscovered, that are always green. It's especially a problem when we are using Objective-C and mocking with the OCMock library. We were sometimes over-mocking tests, so they were always green. Of course, we really like green test reports, but I think we all know that it's not the point of them. We call these kind of tests evergreen unit tests because they are always green, but they say nothing about actual code logic. So we were thinking how we could prevent and solve this problem to avoid such a test in the future, and this is how we came up with the idea of mutation testing. Have you ever used mutation testing in your project? So the idea of mutation testing is that you have your beautiful code, your function, and you also have a test for this function. Then you intentionally create some changes. You create mutants, like this one. So then you rerun your test again, and the tests should fail. They should detect the mutant, because the application logics has changed. If the mutant was not detected and the tests passed, it means that there may be probably something wrong with the test, and they can be evergreen unit tests. So no mutants should survive ever as far as mutation testing. Here are like the examples of mutations you can create. So for example, you can, instead of returning true, you can return false. Actually, the change we did here is also kind of change of the application's logic. You can also negate some conditions. So instead of equals, you have like negation of equality. And you can also change some mathematical operators. Actually, sky is the limit. You can change anything you want. It's only up to your imagination. And to sum up, we learned that code coverage says little about tests quality, because even though the test coverage is high, the tests may be evergreen ones, and they are not checking the things they should. We use manual mutation right now in non-trivial test cases. So every time we write some more complex test code, and we feel that it may be tricky, we always test our test with the test mutations. So we always try to find out if the test is checking what it should be. And we are also aware that not all mutations have value, meaning that not all mutations can be actually reflected by the, for example, production users. So some of the cases are just artificial and we don't have to check them. And we are also aware that there is a project called Mul that actually was presented at Mobius last year, at 2017, and it's a tool for automation mutation testing for iOS. And we are actually thinking about how we could apply it in our project because it seems to be very, very attractive. So every time I see the green test report, I'm wondering if I wrote a really good code or just shitty unit tests.
Okay, so this is how we've dealt with evergreen unit tests. Now let's move to another problem, which is view testing. Does any one of you recognize this screen? Yes, this is the diff for XML interface builder file, and sometimes it's really hard to know what exactly changed in this view and how the view will lays out on different types of devices. So if you want to carefully check it, you need to check out the branch and run the code simulator or devices. And this iteration process is very slow, and we want it to move faster. That's why we use iOS snapshot test case library that originally was developed by Facebook, but now it's maintained by Uber. So let's start with giving an example of how this library works. So Ewa, around 1 year ago, created a subclass of UI view that has 2 labels and 1 image on the left. So Ewa decided to snapshot test it. So iOS snapshot test case library took this image and rendered it into PNG file that we'll call reference image, and this image is saved locally in the repository. 1 year later, I needed to make some changes in this view. And those changes were not affecting layout. They shouldn't affect layout, but as you may see, the label is gone. So now, iOS snapshot test case library again took this subclass of UI view and recorded it into another PNG file that we'll call recorded image. Next, it compared those two PNG files and created a div between them. And as we may see, we have this label missing here. So that's why the test will fail, and we know that the view is not looking as it's supposed to. Under the hood, our snapshot test case library is using memory compare function to actually compare pixel buffers, so it won't iterate over every pixel value, and this is the fastest way possible to actually achieve that. So we use our snapshot test case library not only to detect logical mistakes, but also to see how the view lays out for different size classes. So here we have one UI view controller for compact size class, and here is the regular one. The content is exactly the same, but the views are completely in different positions. Also, we use iOS snapshot test case library to test dynamic type. We know that it's very important for people with less acute vision due to aging or other conditions. So here is the smallest font size. Here is the regular one when you don't change anything in accessibility settings. And here is the largest one. And actually testing dynamic type has one more benefit. We can see how labels are being truncated when there is not enough space to show all the content. So unfortunately, Apple doesn't provide us with some library that lets us to mock those environments. So we need to write a little bit of code ourselves. To mock size class is fairly simple. And what we need to do is to create some parent UI view controller where we embed our view controller under test as a child. Next, we define the traits that we want to test against. In this case, it's regular horizontal size class and regular vertical size class. And finally, we need to override those trait collections on our parent view controller. Mocking dynamic type, it's a little bit more difficult. From code, we can get this font size by calling preferred content size category property on UI application. But as you may see, this property is read-only. So we cannot just set it to any other desired value. That's why we need to use dynamic features of Objective-C and precisely swizzling to return the content that we want to. To do swizzling, we use another popular library that Ewa already mentioned, which is OCMock library, that allows us to do it. So firstly, we create a mock of UI application, then we swizzle preferred content size category property, and we return the value that we want to test against. And finally, we post the notification that the font size changed, so all the views can react to this change. So when we started to using iOS snapshot test case library, we decided to snapshot test everything. And by everything, I mean large view controllers like this one on the right, the sections of this view controller, and also views that are inside of those sections. And imagine a situation when there is a whole team working on this big UI view controller, and everyone is making changes in different parts of this view controller. And those PNG files that I mentioned, the recorded PNG files in the repository, they caused lots of conflicts. So to solve this problem, we decided to not snapshot test such a big UI view controller, such a big views, and only focus on small parts. Another problem we experience is snapshot test overhead. In our project, we have almost 7,000 unit tests, and around 30% of them are snapshot tests. But as we see, test execution time plot, snapshot tests are executing around 75% of time. It gives us that snapshot test is on average 4 times slower than a regular logical unit test. And sometimes for a bigger view, one test can take over 1 second. That's a lot. That's why we need to find a way to optimize it. So in our modular architecture, when some developer creates a pull request, we only run tests for the parts of code that actually changed. So for example, one developer made changes in offer module and cart module, and we only run tests for those 2 modules and our main app target. And it helped us to reduce this testing time drastically. So to sum up, iOS snapshot test case library allows us to quickly verify views layout. It enables us also to test accessibility, which we think is very important. We need to think and we need to be careful when testing large views. And actually, we use our experience to decide if we should test it or not. And we need to think also about measuring our test and find the ways to optimize it if we can.
So this is how we dealt with the problem of testing views using snapshot tests. Now let's move to another test layer, which is about change management. So Allegro, as I think every bigger company, has many teams and many employees working on simultaneously on different features. And our service consists of around 500 microservices. They are exchanging more or less 25,000 events per second on the data bus in the peak time. And this GIF is a little bit blurred because it reflects actual production data, and it shows only some of the microservices and the data that they are exchanging. So in Allegro, change is bread and butter, and by change I mean new features being introduced or some new bug fixes that are introduced to production. And because the system is so complex and because the communication is not always perfect, it's quite hard to predict the consequences of once the introduced change. So our mobile application stability sometimes suffered because change in one place influence its stability in a significant way. And we are thinking how we could prevent and monitor such a situation in the future. And this is why we introduced a set of end-to-end UI tests in our app. They were communicating with the API, and they were run every night. And if they failed, we knew that something is wrong and we need to react accordingly. We wrote them using KIF framework, which stands for Keep It Functional. Do you use this framework? If yes, you can raise your hands. Yeah, great. So at the time when we were deciding which framework should we use, KIF was definitely more stable and faster than Xcode UI tests. I know right now the situation is a little bit different, but we also really like the idea that in KIF, when you are, for example, using method wait for view, you have a view returned, and then you can cast this view and perform some actions, which can be very useful as far as setup and teardown for the tests are concerned. We knew that these kind of tests are dependent on many factors, like internet connection or API stability. So we knew that they may perform a bit slow. That's why we put them in the separate test target. And we were very unhappy to learn that they are flaky. So it means that they are failing randomly, regardless of the code logic. We don't really like flaky tests. I think nobody does, because they hinder development, they cost time, and at the end they cost money. So that is why we tried UI test with a mocked API. It means that test, instead of communicating with the API, with the backend, they were using some mocked API. What we did, we recorded all the requests that application is performing during running tests, and we saved all of the responses in our repository. So all the responses needed for the test are in the JSON files in our repo. Right now, tests can be run offline, and they are more reliable in this way. So we knew that this kind of approach brings one risk. For example, what if something changes in the backend, and this change will not be reflected in our safely stored JSON files? So because of this issue, we are performing scheme validation. So here are our JSON files in our repository, based on which we create a JSON scheme. Scheme contains information about response structure, variables presence, and their types. These two information are stored in configuration file. So configuration file knows what exactly tests expect from the API, and then we compare this information with the actual backend requests. So we can check whether these two information are consistent, and if they are, the remote validation passes, and we are sure that our JSON responses are up to date. Just to better understand the idea, here is the example. We have simple information about auction, which is active. So based on this JSON, we are building a schema which contains information about presence and the type of the response. Of a variable. So we know it's a string, and from our knowledge, from our experience, we know that it's an enum. So we know that the auction can be either active or ended. So in our configuration file, we know exactly what we expect, and then we create request to the backend, and we get information about auction that is being actually finished. What do you think? The test, the validation will pass or it will fail? And why it will fail? Exactly. In the meantime, something has changed in the backend, and instead of ended, we have an answer about a response about finished. So we definitely have to update our JSON schema and write here a finished enum. And of course, we need to adapt our application because something has changed and it may influence the app appearance or stability. So in this way, using mocked API, we were able to have faster and more reliable UI tests. But in the same time, we noticed that our test coverage progress slowed down a bit because not only we have to write tests right now, but we also need to stop the responses and validate the schemas. What is also what we struggle with is also that our tests are run after each pull request to our develop branch, but they are not critical to merge. As developers, we sometimes tend to forget about running them, and this is a problem we also need to apply to make them more unforgettable, because we believe they are very important. And I told you about being less flaky for tests and so on. Here is a small qualitative analysis we performed. So we compared 10 test runs, tests using mocked API and the real API, and we are really happy to learn that tests using mocked API are 70% less flaky, and they are discovering more bugs. So we are quite happy with this small statistic.
Thank you. Okay, so we work hard to deliver new features, new bug fixes, but now it's time for a release. Unfortunately, there are so many things that can go through uncatched. But we came up with a process that makes us more certain when tapping Submit for Review button in iTunes Connect. Allegro is the most popular e-commerce service in Poland, and actually Allegro's employees are using Allegro to do its own personal shopping. And we quickly discovered that giving release candidate to real production users is the best way to test it. And this technique is called Dogfooding, which means organizations' employees are using and testing its own product. And we have two ways to distribute our release candidate. First one is through Fabric beta tool, where we send special app signed with enterprise certificate. And by special app, I mean an app with debugging tools enabled, such as recording network request for later debugging, or additional panel that lets users change API environments. This version of the app is distributed via mobile device management software that's installed on every company-owned phone or iPad. So if you are an employee and have company-owned phone, this app will automatically appear on your device. The second way is through TestFlight beta testing tool that's part of iTunes Connect, and we send there the version that should land later in App Store. And actually, for those both versions, we encourage employees to use it as it was normal production version. To give you a little bit technical details, for continuous integration and deploying the app, we are using Bamboo service, and any developer, product owner can go to Bamboo webpage and tap deploy button, and this app will take current code from development branch and deploy it to TestFlight or a Fabric beta tool. Under the hood, Bamboo is using Fastlane, which automates lots of things such as building the app, signing the app, and deploying the app. Unfortunately, our deployment plan is taking around 30 minutes. And sometimes there are situations when we need to release our app very quickly. And we cannot afford this plan to fail multiple times. That's why we created a completely separate plan that's called Daily Deployment Check that runs every night and actually checks if our deployment plan is working without submitting the app to other service. When deployment plan is not working, it will inform us on separate HipChat channel, so the next morning we can fix it, so deployment plan won't surprise us on release day.
Let's move to another problem, which is testing in laboratory condition. So what do I mean by laboratory condition? When testing, we are mostly sitting by the desk, having great Wi-Fi connection, and we are actually performing test cases. It's really hard sometimes to behave as a real user when you are a developer tester and you are maintaining the application for some time. And we experienced a problem because of this laboratory condition testing. We introduced a feature that was synchronizing locally stored items to the backend. We implemented, tested it carefully, at least we thought so. But then we saw comments saying, after latest release, application crashes. Of course, we were very sad because we thought that we did our best, but definitely it wasn't the best that could be done. It appeared that they were users on production, really heavy users, that were having hundreds of items, of these locally stored items, that were about to be synchronized, and we didn't test that case. We didn't know that there are users that have so many items. So we were thinking how we could think more like a user, or how we could perform cases like a real users do. As a solution for this problem, we are using phased release. This is a feature that Apple introduced last year during WWDC 2017, and it enables developers to roll out application only to the part of the users. So if anything is wrong, you can stop rolling it out and limit the exposure, and you have a time to react. What is important to mention is that this feature only concerns automatic updates, meaning that a user is always able to go to App Store and update manually. Also, once the user installs the application's version, it's not possible to pull it back. So the user will be stuck with this current version unless he or she updates it. So this kind of release strategy is called, maybe you recognize the small bird, and maybe you know this term. Yeah, it's about canaries. It's a canary testing, canary release, and it's connected with the British mining history because canaries were used to warn miners of carbon monoxide that is quite toxic to people, and these small birds are very sensitive to this gas. So they were warning miners so they can evacuate quickly, and they were saving their lives. So, of course, we are not saving lives in our application, but we are definitely saving at least our salaries, maybe. So, yeah.
Okay, so let's move to next problem we encounter, which is decision making. Recently in our app, we released a new feature that lets users compare items between each other. Due to limited screen size, we can only show the most important characteristic of an item. One of such an item is the review of the seller. And in this example, we show a label that says 100% of buyers recommends this seller. But also we wanted to give the user an option to go into detailed review information screen, such as reading every review, see negative, positive comments. And we came up with 3 ways of how to do it. First one was to make this label tappable. The next one was to add accessory view on the right. And the last one was to add explicit label on the bottom that will say, see all reviews. So now we have 3 different variations, but we don't know which one will perform the best. And by performing the best, I mean the version for which the number of people going into detailed review information screen will be the highest. So for situation like this, we use A/B testing, which works by deploying all those 3 variations to the production in the same time. And to do it, to manage those A/B tests, we use Optimizely. And actually we choose Optimizely because other teams at Allegro are using it, and we wanted to stay consistent. And this is how example report for Optimizely looks like, and based on this report we can make data-informed decision. So let's talk a little bit about how we manage A/B tests in our modular architecture. So A/B test runs in our offer comparison module, but the Optimizely third-party framework is linked to our main app, and there are 2 reasons for that. Firstly, we run A/B tests across many modules at the same time. So we don't want to repeat ourselves and link Optimizely to every module. That's the first reason. And the second one is we want to make completely transparent which provider we use. So for example, if in the future we change from Optimizely to Firebase, we don't want to make any changes in code in offer comparison framework. So now we are in offer comparison framework. And firstly, we need to define the types, the variants that we support. So in our example, those are those 3 types. Secondly, we need to define some protocol that will return the desired variant type that we need to present. And somewhere in offer comparison framework, we have initializer that accepts object that implements the offer comparison A/B test managing protocol. And our main Allegro app target, we actually using third-party optimize the framework to get the desired variant type. And we create some object that implements this protocol defined in offer comparison module, and we return the desired variant. And this is actually everything we need to do to support such a A/B test. So now our app is available to download from App Store. We don't see any crashes in Crashlytics. Everything seems fine, but we have still one big problem. If the users are happy with our app, with our features, we don't want to just build the product the right way, we want the right product. We can see partial happiness in App Store reviews, but we all know that there's lots of noise in them. For example, sometimes we get reviews like, this app is a toy, I have nothing to say. We know that the user is unhappy, but we don't know what to do to improve. That's why we do usability testing, and we actually invite real-world users to our office. And we ask them to go through critical scenarios through our app. What's really cool, every employee can go and sign up for such an A/B test and observe the user how they go through those different scenarios. And for example, one such a scenario would be adding an item to a cart or adding the item to compare between each other. And we ask users when they do it, what they like, what they didn't like. We observe how they react with the application, how they perform certain actions. We invite different type of users, younger people, older people, people less experienced with our platform and more experienced. Finally, the report is constructed and sent over to all Allegro's employees, and product owners can decide what should be done. So we've talked about 8 real problems that we encounter during our daily work and 8 solutions that we came up with. We want to highlight that this is still an ongoing process, and new problems arise, and we need to modify current solutions and find new ones. And we hope that it was valuable for you, and maybe one of those test layers you can use in your own products. Thank you very much for your attention, and we are here to answer any of your questions.
Yeah, thank you for the session. I have one question: how you perform the localization testing, or you use the Polish language as development language? Thank you.
Yes, we use Polish language, and this is the only language that we support currently in our app.
Okay, maybe you think about the growing your application to multiple countries and multiple customers. Yes, because I was seeing that there was any customer from the UK that wrote the comments.
No, that was actually the English translation of the Polish comment, and the flag was only to indicate the language, but maybe it was not clear. But we used to support other languages, also Russian
and Czech,
and Hungarian, and Czech, yeah, and Czech as well. Yeah, I think we had all 3 countries being supported.
So
Ukraine as well. That's true.
So you have the plans, yes, to expand the testing infrastructure to test the other language. For example, the view comparison tests will fail in other language, not Polish.
Yeah, right now we do not support other languages, so if you would change the language, they would fail. But definitely snapshot testing is a good tool to also snapshot different languages on views.
Yes, but we don't have any business need right now to support other languages. That's why we don't write tests against it.
Mm-hmm. Okay, thank you.
Thank you.
Hello, thank you for your talk. Can you tell me, did you try to use resources like test.io, like outsourcing testing resources that have external testers and can go through different scenarios and find the bugs?
Could you say the name?
Test.io, for example.
Test.io. No,
it contains a lot of like freelancers, testers, and they can try to find the bug and collect the information.
You mean like it's a service when we ask other people to test our app?
Yeah.
We haven't used it because we have our
resources. Like
yes, let's say so, because we have also Alek was talking about beta testers that are like in company. So these are like, it's Dogfooding is concerned. Yeah. We also have beta testers like internal ones, like it's usually a group of people involved in development. We also have external testers in the company, but the numbers of people who are helping us with testing, I think they are still not satisfying for us. So maybe that would be the good option to consider. What do you think?
Yeah, but also we have really strong security department
That's-
in our
that's also
company,
true.
and I think it could generate some. We don't know.
Yeah,
Actually,
yeah, but
it's hard to answer this question.
Definitely, it's a good idea to research more.
Yeah. Thank you.
Thank you.
Hi, thank you for this. And my question is about updating snapshots. When you change your UI, how do you update snapshots? Is it automatic procedure or manual, maybe?
It's manual, so if you're a developer and you know that you need to change visual layout of some subclass of UI view, you just manually change the code to record the snapshot test again, you commit the changes, and that's it. Because it could be more automatic, but we want to, like, if you know you're a developer, you are changing, then you explicitly say, okay, I changed this, new snapshot are required.
Hi, thanks for your talk.
Okay.
Question about Dogfooding. How many days feature waits in Dogfooding step before beta or open release?
So how early do we spread the version before actual release?
Okay. And what is the time that it will spend in Dogfood step?
It depends. Sometimes we have releases that there's no bugs, on like very small ones, and we can release it to an app store. But sometimes we had releases when there are a couple of really serious blockers, and it could go. We have a goal for this actual year to make our release very scheduled. So we want to release our app every 2 weeks, to be more, to know our tools better, to have better process. But right now we know that we need to release. We do dogfooding, we test it internally by regression, and it depends on how many bugs are detected during this process until we actually release to the App Store. So it varies a lot, actually.
It may be like 2 days or even a week.
Yeah.
So dogfooding is optional step.
Actually, yeah, it's not required, but right now.
Like, it's not required because we have our own internal regression, and like this should be enough, but also there are bugs. Like, for example, we have 3 teams in 3 different cities, and for every release there's one city that should release the app, and it's responsible for the release. So for example, we do regression in Poznań when we release app in Poznań, but for example, people from other cities such as Wrocław or Warsaw can submit bugs, and we treat it as a dogfooding, and it's completely normal. It happens every release.
Thank you.
Thank you.
Hi, thank you for your talk. My question about mutation tests, because the most layers that you mentioned are commonly used in different. It's used in development practice. It's okay. We know it, but mutation tests is quite different. Can you tell a little bit more? I mean, how do you use it? You said that you use some manual, mutation tests. So you write like different objects that in them change some stroke of code. Yes, and please tell a little bit more about it.
Sure. So I think mutation testing is especially useful if, for example, I'm not that experienced in writing unit tests. So I always double check whether my test is doing what it should do, and how it looks like. So you have a like this function you got here. So at the beginning there was success closure being called, but if I want to check whether my test is really checking if this closure was called, I, for example, change success for failure. So I'm just opening one class or one function, I'm displaying it in the Xcode, and I'm just changing the code, changing the logic, negate the conditions, change mathematical operators. And then when I have this change done, I rerun my tests, the tests that are already written. And if the tests fail, it means that, okay, it's cool because they detected the mutant. So by changing actual application's logic, I'm checking if my tests are doing what they should do.
And it's more like manual process that we use in our team, and we communicate about it. There is nothing that we automate, but we are all familiar with it and we do it on a daily basis.
Do you use it a lot?
I personally do it a lot, but I know that it's not also required. It's a tool. It's an approach that can be done. I'm not sure. Do you use it often?
Yeah, I use it.
Yeah. Okay.
Okay, thank you.
Thank you guys for your presentation. Really great processes on your project. You mentioned that this regression testing, do you perform it manually or it is automated too?
So you mean about a regression test before the release procedure, right?
Yeah.
Yeah, so we have part of the UI tests that are being automated. So these are the tests that I was talking about with mocked API. And they are also checking the very critical paths of the application. But not only these automated tests are being performed before the release, we also have a set of manual test cases. And our goal we had this conversation about how much we want to have automated regression and what part of regression should be manual. And right now we have both automated and manual. But ideally it would be to have more automated test cases and less manual testing. But of course we believe that automation is also doing checks, the checks that we define. So we believe that also some manual test would be required before actual release.
And how many time does it take to perform all of these UI tests?
Yeah, so as a team, because we try to, when we release, this is the most important thing that is happening in the project. So we always try to perform regression tests all together as a team. So there are around 6 people, like 6 developers. So it takes us like 1 day. And if there are no critical bugs, we are ready to release. But if there are bugs, of course we need to hotfix the release and so on. But I think it's more rather issue of quality than the regression as itself.
And UI tests are taking around 40 minutes, something like that.
I think shorter. Right now it's
30?
yeah.
Great, thanks.
Thank you.
Thank you guys. You've done really great job. You wrote a lot of tests, so it's pretty obvious for me to ask a question. Who are those guys or girls who write all of those tests? Because, it's about test-driven development. You can write tests as a good representation of how your code actually works. So I wrote this module, then I wrote tests to explain how my code should work. The second one is the product owner should write tests to explain how he expects his product to work. It's called functional tests. And the third one is UI tests. So it's probably not a work for the developer to write UI tests, usually separate UI automation engineer or somehow. So I'm just wondering, how are those roles in your company? Or it's always the one person, it's usual developer who can make all the things.
Okay, so let me answer the first question. If we are writing unit tests. So unit tests are required for every code that's written in testable way. So I don't think there is a way for tests, for pull requests to be merged before the developer writes tests to it. And actually, developers and testers also make features and pull requests, so we as a team have this feeling that our code needs to be covered with tests, because our app is maintained through a lot of time, and we write one feature, we completely forgot about it, and the tests are the only way to make us certain that this feature still works after a couple of times, after a couple of months when we forget the code, when we forget what was the requirements for the feature. And the second question was about
snapshot test, right? Or
just about every functional test, because product owner can tell you, I expect some things to work like this. Usually, some companies have a position of a technical writer who translates words from managers, product owners to the technical word, so developer could understand it. And and it's usually better to just write tests, not just some words.
Of course, yeah. The tests are like living documentation, so it's better to maintain tests than just documentation. I agree, but we don't have like BDD, so behavior-driven development or behavior-driven tests. So we don't use Cucumber or something. Our functional tests are written by developers, so by testers and by programmers. And every time we feel that some test case should be automated, of course there are testers who have the biggest knowledge about what should be tested and so on. But we are trying to involve everybody in the writing tests procedure, especially as I was talking about mocked API tests. They're quite technical and quite complex, so it's really fun for developers and testers to do them, because there are many things still to improve. So I believe this is still living procedure. So the short answer is that each developer can write such a test.
And have you tried to let someone else to write tests for your code?
Someone else? You mean somebody from other team, or?
Or maybe your team, just like a cross review, but cross test, right?
Yeah, as Oleg said, we have 3 teams working on the same project. So they're located in the different cities, and we communicate a lot. And I'm sometimes doing like cross testing with some testers with the other cities, or also in the code review, everybody takes part in code review, so you meet somewhere in this stash and you are exchanging comments. It's the same for tests. So I treat it as a person from another place, from another perspective, that can give me some insights that I was not aware of. I'm not sure if it answers your question.
You can just write tests and give it to your developer, and he just checked his code and realized that it's not working on your tests. It's work on his tests, but not on yours.
I'm sorry. Time is over.
We can discuss it later.
We can talk in discussion zone. Thank you very much.
Thank you.